Hi guys, today we are going to talk about implied volatility, what it means and how we can use it. I covered implied volatility briefly in the past, but I'm going to go more in depth on this topic today. To start, implied volatility can be thought of as how much a stock is expected to move in the future, and IV is shown as a percentage. So how to read IV is, the higher the IV percentage, the larger the possible move. A 40% IV suggests a larger move compared to a 20% IV. But keep in mind that this is only a possibility. The stock might make a smaller or larger move than the range indicated by implied volatility. This move can also happen in either direction. For example, if you have a stock ABC with an implied volatility of 20%, if a 20% implied volatility equals an $8 move, this means at the current price, ABC can either gain $8 or lose $8. So we see that IV tells you to expect a move, but it can't tell you which direction it will happen, and it can't guarantee the size of the actual move. What are some possible factors that can affect IV? Well, any upcoming news that can impact the company can affect IV. For example, a company's earning report, upcoming product launches, or news of possible mergers and acquisitions happening. These events affect IV because they can impact the company positively or negatively. In general, when there is fear or uncertainty, the implied volatility of a stock tends to go up. Once the event has passed, IV goes back down. Implied volatility is also higher during bearish market due to there being more uncertainty in the market, and it is lower during bullish markets. An example of one of the factors that can affect IV. Here is a screen capture for Apple on the Thinkorswim software. Every row is an option for Apple. Each of these options have different expiration date. They also have different implied volatility. The percentages on the far right are the implied volatility for that option. You see that the option expiring on 30th April has a much higher IV compared to the option expiring on 23rd of April, 41.9% versus 25%. The reason for the difference in IV is because Apple's quarterly report is scheduled to be released on the 28th of April. Since nobody knows if this report will be received positively or negatively, because of this uncertainty, IV went up. As the option expiring on 23rd of April is not affected by this quarterly report, its IV was much lower. How can you use implied volatility to help you with options? You can use IV to help predict the price range of a stock after a certain period of time. The default time frame for implied volatility is usually 1 year, and implied volatility normally refers to one standard deviation. To find the price range, you need to understand what a normal distribution is. So I will have to go into some mathematics right now. A normal distribution is also known as a bell curve because the shape of a normal distribution looks like a bell. Many events in real life follow a normal distribution, such as height and weight, shoe sizes, income, or blood pressure. Let's look at some of the characteristics of a normal distribution. Here is the center of the normal distribution, and a normal distribution is symmetric. This means the data on the left-hand side is the same as the data on the right-hand side. If the data on the left is 50 units, the data on the right is also 50 units. They are mirror images of each other. The area under the blue curve shows how the data is distributed, and you can see that the area near the center is the largest. In a normal distribution, you can expect to see around 68% of the data located within one standard deviation of the center. In simple terms, this means that most of the data or outcomes in a normal distribution are located near the center of the normal distribution. Remember earlier I mentioned that a lot of real life events follow a normal distribution? What I mean by this is, Let's say you decide to record the height of 10,000 males. If you recorded all their heights and you plot it on a graph, the final shape will be similar to a normal distribution. There will be males who are very tall, taller than 190 cm, and there will be males who are quite short, shorter than 154 cm. But the majority of males will be located around the center of your graph, and they will have an average height of around 166 cm to 176 cm. So the distribution of the height for males will be similar to a normal distribution, with around 68% of the data located around plus minus 1 standard deviation of the center. And this is not only for height. If you look at the distribution for weight, income, or blood pressure, they all follow the normal distribution. I use the term standard deviation quite often when talking about normal distributions. Let's explore a bit further on what is a standard deviation. The official definition for standard deviation is it is a measure of the amount of variation or dispersion of your data. But to keep it simple, you can think of standard deviation as an indicator of how spread out your data is. A high standard deviation value means your data is very spread out and far from the center. A low standard deviation value means your data is quite concentrated around the center. In a normal distribution, you will expect to see around 68% of the data within plus minus 1 standard deviation from the center. 95% of the data lies within plus minus 2 standard deviation from the center, and 99.7% of the data within plus minus 3 standard deviation from the center. I found a video that does a great job explaining the normal distribution. I will put the link in the description below. I highly recommend you to check it out. From that video, you will see that in a normal distribution, a large majority of outcomes lies near the center. You know this is true, even if you can't predict how each individual event will be. The most important question you would probably have right now is, what's the point of learning all this and how does it relate to options? Well, the day-to-day price movement for a stock is similar to a normal distribution. Just keep this in mind. I will show proof in the future. Because it is similar to a normal distribution, you can actually calculate the price range for a stock. Implied volatility is based on one standard deviation, and the time frame is usually 1 year. You can use implied volatility to calculate a 1 standard deviation move, and from there, you can find out the price range of the stock. Here's an example of how to do it. Let's say the stock TSM is currently at $100 with 15% implied volatility. To calculate how much TSM will move based on 1 standard deviation, you multiply TSM current price with its implied volatility. So 1 standard deviation move is $15. Treat the center of the normal distribution as TSM's current price. As 1 standard deviation is $15, this means 1 standard deviation above is $115 and 1 standard deviation below is $85. Since you know that 68% of the data lies within 1 standard deviation and the time frame for IV is 1 year, this means that there's a 68% probability that TSM's price will be between $85 to $115 1 year from now. And if you increase the price range to 2 standard deviation, there's a 95% probability that TSM's price will be between $70 to $130 1 year from now. As you widen the price range or increase the number of standard deviations, you become more and more confident that the future price for TSM will be within that range. However, please be careful and note that just because there is a low probability for the stock to be outside that price range does not mean it can't happen. In this example, at 3 standard deviation, the price range will be $55 to $145. Even though the current implied volatility is saying that there's a 99% chance that TSM will be in this price range, It does not mean that TSM can't be lower than $55 or higher than $145 1 year from now. Always be aware of this. The same also applies when calculating 4, 5, or even 6 standard deviations. So using implied volatility and the normal distribution can help you find the probabilities that a stock will be in a certain price range. And you can use this information to help you decide whether to buy options on the stock. Now you might have a question. What if my time frame is longer than a year or shorter than a year? How can I calculate the probabilities? Don't worry, in my next lesson, I'm going to show you a simple method you can use to find out what are the probabilities and price ranges for a stock, regardless of any time period you are looking at. Thank you for watching. See you in the next lesson. As always, feel free to leave a comment if you have any questions and I'll do my best to reply. If you found the video useful, it would be awesome if you could like the video and share it. If you have the means and you would like to support the channel, I have a link to my PayPal below. Any donations will be very much appreciated. Thank you.